Hello and welcome back to College Algebra MAT 150. In this video we will be graphing and talking about the vertical line test from section 1.2. For most of our applications we say that y is a function of x. Because of that you can just replace f of x with y in many instances, as we've already kind of seen. So how do we graph f of x equals negative x plus 1? Well, again, really, you don't have to actually do this, but you just know that this is y equals negative x plus 1. And when you graph lines, you're really using slope and the y-intercept, so 1. So the y-intercept is 0, 1, and then we have a slope of negative 1, which we can think about as negative 1 over 1. So the rise over the run, we go down 1, right 1. We get another point. And then down 1, right 1. And then we can go the opposite way, up 1 and left 1. We get this and keep on doing this indefinitely. And we would ultimately get this graph. Alternatively, if you don't remember this, and we will be going back over this in more detail later. This is not a perfect graph, by the way. We will, you can also try a table of values because this is a function. So you could do, again, every input should only have one y output. So for example, if you plugged in negative 1, negative of negative 1 is 1, plus 1 is 2. So negative 1, 2, which is what we have here. 0, if you plug in this, so negative of 0 plus 1 is 1, 0, 1, which we have there. Or you can plug in 1, negative of 1 plus 1. Negative 1 plus 1 is 0, which is what we have here. Again, 3 points should be enough to make a line. And that's all we have. Again, we will be doing more graphing later, and we will show more techniques, and we'll even revisit this a little bit later. So with that out of the way, so if on the graph of an equation you can make a vertical line that passes through the graph more than once, then we can say y is not a function of x in that equation. Or y does not represent, cannot be represented as a function of x. This is known as the vertical line test for the graph. Similarly, if every possible vertical line can only go through the graph a maximum of once, then y can be represented as a function of x for this graph. So it goes both ways. So in this, that we did call it a function, does it pass the vertical line test? Well, no matter where I make a vertical line, it goes through it at most once. Again, remember the arrows means it goes on forever, so even if I made it like way over here, it would, or way on the other side. Okay? So that's the vertical line test. And with that, just looking at a graph of a function, we can quickly determine if, that's what we're at a graph of an equation, or just any graph really, we can determine if we can represent that as y as a function of x. Okay? So in this particular instance, determine if the following graphs if y can be represented as a function of x. Well, I say below is the graph of f of x. Well, below is a graph. And I say that very specifically over here because if we make one vertical line, so we use the vertical line test, say here, it doesn't have to be here, it could have been here as well, doesn't matter. We only have to be able to make one vertical line. Here we can make literally infinitely many. And when we can make infinitely many, that even just one rather, that goes through the graph more than once, then this is not a function. So y is not a function of x in this case. Okay. Similarly, below is a graph And this was our answer, by the way. So below is a graph. But what about here? Can we draw a vertical line? And is there any vertical line that we can draw that will go through the graph more than once? So if we draw a vertical line here, 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 and it seems as we went over that way it wouldn't. We're over here, we're fine. The only weird spot is here. So this hole means it gets really, really close to this point, but it doesn't actually reach it. This filled in dot means that we do actually get to this point on the graph. So the only weird place where it looks like we might have some overlap is possibly here. But notice that at this point, when we're looking at this sort of line, does our vertical line actually intersect the graph here? No, it does not, because it's a hole. Again, it gets really, really close to that number, but we don't actually reach that point. Versus here, it does actually intersect since it's filled in. So in this case, that was the only possible problem place, and it still only goes through the graph once. So y can be represented as a function of x in this case. All right. And that concludes this portion of section 1.2.